All right, section 5.7, solving quadratic inequalities. So it is very similar to linear inequalities, just now it's a quadratic. All right, so we're going to solve quadratic inequalities by using tables and graphs, more graphs than tables. And we're going to solve quadratic inequalities by using algebra. So some steps when you're looking into graphing quadratic inequalities, very similar to that of linear inequalities. Okay, so first you're going to graph your function. So we're going to graph the parabola based on what the inequality says. And then you're going to use solid lines for greater than or equal to, less than or equal to, and dashed lines for less than or greater than. Same thing as with linear inequality. And then you're going to shade above the parabola, okay, for anything that's y is greater than or equal to, and then below the parabola for y is less than or y is less than or equal to. So same concept as what we were doing with linear. Okay, so this stuff, like I told you, what I taught you before, you will be using again, at least in this course. So let's look at the first example, right? Y is greater than or equal to x squared minus 7x. All right, so there are my 4 points. All right, so that's my y-intercept, 0, 10. These are my zeros, x equals 2, x equals 5. And my vertex, 7/2, comma, -9/4. All right, now I have enough information that I can graph the rest of my parabola, so connect the dots. Okay, now it is a solid line because it is greater than or equal to, so that's why I use the solid line. And then since it is greater than, all right, greater than, so whenever you're thinking greater than or less than, look at the y-axis. Okay, look at the y-axis. All right, you want all values greater than the parabola. So this parabola here to be greater than this. This is the parabola. To greater than this, I want everything up here. If I wanted less than, it would be everything less than. So based on the values on the y-axis. All right, so I'm going to shade above it. So that is the solution to my graph. Okay, we can still check these. Yay, I love checking my stuff to make sure I'm right. So test the point that's within the graph. All right, I'm going to test the point 4, 0. All right, because I looked at the graph that looks like it should be part of my solution. Plug it in. All right, everywhere there's an x, plug in 4. Everywhere there's a y, plug in 0. If the statement holds true, we shaded properly. All right, 4 squared 16. -7 times 4 is -28. Do the math. 0 is greater than -2. Bam! That's correct. Woo! All right. There's your first now you try. Okay. Graph it, right? If you printed out the guided notes, there is a graph on there. You have to bring that with you. You cannot enter that online. All right, so you graph that and bring it in if you want credit for doing your work. All right, next what we're going to do is we're going to solve quadratic equations by using algebra. So we're going to, that was graphing, now we're going to do it algebraically. All right, here's our equation, x squared minus 10x plus 18 is less than or equal to -3. So we're going to write it as an equation. So right now we're going to take the steps right as an equation so we can solve it. All right, so instead of less than or equal to, it is now equal to. From there, you're going to write it in standard form. So that means add 3 to both sides. So you get x squared minus 10x plus 21 equals 0. All right, now I have my quadratic that I can factor. So let's factor it. Okay, I know by looking at it, if you're still working on it, take the factors of the 21. All right, understand that process. I know it's going to be -3 and -7. All right, now I can solve for x for those values, find out what my zeros are. We call these the critical values. All right, when you're dealing with inequalities, those are the critical values. All right, so x minus 3 equals 0 and x minus 7 equals 0. Solve for x in both equations, you get x equals 3 or x equals 7. With that information, okay, graph them on a number line. All right, so 3 and 7 are my 2 critical values. I need to pick a point from each interval. So I need a value from 3 down to -infinity, from 3 to 7, and then from 7 from greater than 7. So I'm going to choose 0, 5, and 10. I plug each of them into my original inequality. All right, so I plug 0 in. When I plug in 0, I get 18 is less than or equal to -3. That's not true. So you get buzzed. Try 5, all right? Plug in 5, I get -6 is less than or equal to -3. Good job. I plug in 10. I get 18 is less than or equal to -3. Also not true. Okay, so I tested the point, so I know what works. So I need to graph that final solution. Holds true. In doing that, I get the values between 3 and 7 inclusive, so it includes the 3 and the 7. And to write that out as an inequality, I get 3 is less than or equal to x, which is less than or equal to 7. All right, so let's look through one more before you get your now you try. All right, so we're going to solve the inequality x squared minus 6x plus 10 is greater than 2. So first step, write the related equation. So replace the inequality with equals. Step 2, write in standard form. So I'm going to subtract 2 from both sides. Gives me an 8 instead of a 10. Now I'm going to factor it. All right, -4 and -2. Find the critical values by setting each part equal to 0. When I do that, I'm going to end up with x equals 2, x equals 4. So those are my two critical values. So now that I have my critical values, graph them on the number line so we can get our intervals. All right, that's my number line, my intervals. So I need to pick values between -infinity and 2, between 2 and 4, and between 4 and infinity. All right, so I'm going to pick 0, 3, and 10. All right, when I plug in 0, I get 10 is greater than 2. That is correct. It holds true. I plug in 3. I get 1 is greater than 2. That is not the case. And then I check 10. I get 50 is greater than 2. We have a winner. So now I can identify my interval which holds true for this inequality. So I'm going to graph that final one. So my final solution is -infinity to 2 and 4 to infinity, not including 2 and 4. When I write that as an inequality, I get x is less than 2 or x is greater than 4. Okay, so this section is bringing back a lot of stuff from what we did before. There's not a whole lot of new. This one's really just combining a lot of the old stuff. Okay, so we got to work through these using the information that we learned before. Like I said, a lot of this is coming back. This is the stuff that we've done before. We're just putting things together. So if you learned it before, you're in really good hands. If you didn't learn it before, let's make sure we learn it this time. This is your now. You try this one. You can actually enter in online. All right, so give me an inequality as your answer.